Good morning, everyone. Hi, my name is Karthik Paul. I'm working as an application engineer in Beacon, and along with me, we have Sindhu PT. She's also working as an application engineer, and she's an electrical specialist. And today, we will be discussing a little bit about how industrial equipment designs happen and how Solidworks can actually help you in this particular designs. So let's start. And before I start, I just want to convey that Beacon is conducting a series of webinars about different industry verticals and how Solidworks can actually help for these industry verticals and how the various solutions are actually going to help. So do try to attend, and let's just start the agenda for today. So basically today what we are going to discuss about is a little bit about the industry challenges that are focused on this particular industry vertical, our solutions portfolio, and then we will be discussing about the various solutions and how it is actually going to help us. So talking about the industry challenges, when we are talking about industrial equipments or any particular designs, reaching at first to the market is quite important, right? You actually have to beat your competitors and you have to reach first at the market. Now that is one part of the story, but on the other side, you reaching at the latest is important, but at the same time, you also have to make your design smarter. And what I mean by being smarter is that the person who is handling your particular components or your particular products have that feeling that it's an innovative product, it's something new, right? At the same time, you also have to think about the cost. You have to reduce the cost at the final stages of manufacturing. One more particular scenario is you have to reduce the number of design cycles, because at various development stages, if some error happens, you again have to work on your design. That is overall going to increase the time in which actually you're working on that particular project, right? So you have to save your time. You have to think about making a smart design. You have to be innovative about it. So let's have a look at what SolidWorks solutions are. So when we are talking about starting off a project, we usually start with a basic concept or simple design so that we can see the working of it. And SolidWorks has introduced some new tools for this. We have the X design and the X shape. X shape is actually a subdivision modeling surfacing platform. Also, X design is a parametric modeling software that works just like your SolidWorks. Now, both of these solutions are actually cloud-based, so you can have your login credentials and you can directly work with them. Now, when you're talking about building your products, in today's scenario, if you see, there is no just mechanical products. It's always integrated with electricals and electronics. And SolidWorks understands this, and it has actually integrated SolidWorks PCB and electrical so that down the line there will be collaboration. Down the line there won't be any errors, and also you will be able to collaborate between different departments. Now, once your design is done, you might want to think a little bit about validating it, checking whether it's actually going to work in the real world scenario or not. For that, SolidWorks has introduced a suite of simulation products. For example, structural analysis, suppose you wanted to do, you can do it. And if you also want to do some kind of flow analysis on top of your models, you can also make use of CFD in SolidWorks. And if you're doing some plastic injection molded parts, you want to check whether your mold is completely getting filled, or if you have some shrinkage losses, you can do it with a plastic solution. Now, SolidWorks thinks that we actually have to work in parallel. That is, your marketing content has to be worked in parallel with your product development. And that's why we have a suite of products that is going to address this. Whenever you're purchasing any product, you have these assembly instructions or you have these maintenance manuals that has to be done. And SolidWorks Composer is actually going to get your 3D contents done very fast. And in the market, if you see, before a product is being manufactured, you can actually see the content online. That is the rendered images or the animations. Basically, they are capturing the market before the product is manufactured itself. And that's what SolidWorks Visualize is actually going to do. And if you want to communicate your designs with your customers or prospects or anybody like that, you can actually make use of e-drawings, which is going to share everything in 3D. Along with that, you also have AR and VR support. Finally, if you're talking about manufactured products and the quality, because you can actually save a lot of time in quality process. And Inspection is a product that is going to streamline your project creation, at the same time your balloons and everything. And if you're talking about manufacturing, SolidWorks Scan is actually going to provide you with all the manufacturing programmed codes that is automatically generated based on the product that you actually want to design. And you can directly feed it into your machines and you can get the manufactured product. Now, what happens is we are actually modeling a 3D. We are actually doing 3D modeling. At the same time, we actually are manufacturing a 3D product, right? But when it comes to manufacturing, we are giving them 2D drawings. Now, 2D drawings are good, but it tends to be a little bit difficult to understand. At the same time, there's no PMI information attached to it. So in paperless drawing, in the 3D modeling, you can directly add your annotations over there. Now, finally, if you are talking about draft site, if you want to do some 2D layouts, if you want to do some engineering and construction drawings, you always have draft site to thank for. Now, if you ask any company, what is the most important thing, they will say it's the data. That is the information that they have gathered throughout the years. And if you want to manage this data, if you want to share, secure, at the same time, get your approval processes done, we have a suite of data management solutions called as Solidworks Experience. Now, at the same time, if you want some PLM capabilities, like you want to handle your projects, you want to manage resources, you want to do some item management, we have managed thank for. At the same time, SolidWorks has also introduced a new platform called as 3D Experience, which is all about cloud collaboration. You can post your designs, you can comment on your designs, you can do some markups, you can even save your designs online. So that's a little bit about how SolidWorks portfolio is actually going to help us. And today we will be discussing a little bit about product development, where you will be able to see part designs, assembly designs, a little bit of drawings, and then we will be taking care of validation. What are the different suites of validations and how this analysis is actually done. Then we will also see a little bit about how the marketing content can be created, your assembly instructions, basically your rendered images, animations, and so far. And finally, my colleague will actually take you through how this electrical collaboration that I was talking about is actually going to happen. So let's just quickly jump to the content. Let me just open SolidWorks and let me show you how it is actually going to look. So over here, I have a model, right? This is a square robot model. Basically, this square robot is what actually goes into these big pressure vessels, petroleum tanks, where people cannot actually access and repair. It just goes with its cameras and its LEDs, and it captures the images. It also does some minor repairs here and there. So that's what this particular model is actually going to be doing. So let me just hide a few of the components and let me just showcase you what are the parts that's inside. You'll be able to see that there is a transfer card, a little bit of sheet metal components, and we have this LED assembly over here. So let's just quickly take care of it one by one. So let me just close this model. So let's just talk a little bit about what happens when it comes to structural members environment in SolidWorks. So basically we have a cart over here. So let me just open this. And down here, you can see some features, right? Now in these features, you can see some rectangular cubes. What basically happens is you can actually save different kinds of profiles in SolidWorks. And these profiles can be reused at any point of time so that you can actually just put the data over here and automatically those structures is going to be created. So any kind of structures you want, you can actually build it very easily. All you need is a sketch and some profiles. You can add as many profiles as you want, and it is directly going to happen. Also, SolidWorks gives you the capability of trimming. You just have to specify the boundary and automatically it's going to do it. You have different kinds of trim options also. Based on what you want, it is actually going to do it. And whenever you're creating such things, structure members, what is the basic idea behind it? You want to know what is the total length of this particular structure, right? Whatever cutting tubes that you are doing, you want to know the length. So SolidWorks automatically creates this cut list where you can get to know what is the length of each of the tubes. And down the line, if you are going into the drawing environment also, they will be helpful because you will have that cut list tables where you can actually see the length of each and every tubes. Also in SolidWorks, you can add equations. So here we have seen that there's an equation that is actually going to tell me what is the total cost of my product. So in SolidWorks, we can add this custom properties. Down the line, you can use it in drawings as well. I'm just going to add total cost over here. I'm just going to specify one of the equations, and my equation is actually going to be this one. I'm just going to multiply this with the mass of this particular product. So I'm just going to add, and SolidWorks is automatically going to fill that information for me. So information like this can be added, and down the line, you can also use it in your drawings as well. And once we are done that, you can also see that SolidWorks has an inbuilt library of different kinds of materials. Now, all these materials you can actually just add to it, and all the mechanical properties are already there. So any kind of material, once you add, you can actually know the entire mass of this particular body. You can know the mass, you can know the center of mass, which is kind of important when you're talking about designs. So let's just close this. Let's just take a look at different kind of design right over here. So let me just quickly change. Let's talk a little bit about the sheet metal environment. Now, whenever you're talking about the sheet metal environment, what do you basically want? You want the flattened length, right? That's the most important aspect. And solvers take care of this by using something called as gauge tables. Now, these tables can actually be loaded from your Excel sheets onto the SolidWorks environment, and you can actually select the gauges that you want. Once you have selected a particular gauge, you can also select the bend radius that you want, and the KT values is automatically going to be taken care of. So that whenever you are actually going to flatten this particular model, it is automatically going to give you the bend lines along with whatever bends are there, and it is actually going to give you the entire length of this particular sheet that you can actually cut. So using that, you can actually check what is the flattened length. You will understand what part of the sheet metal actually has to be cut. Now, along with this, you might also want to add some additional functionality. For example, you want to add some forming tools. That's where the design library of SolidWorks comes into picture. Now, in this design library, you will be able to see that you can actually add any kind of custom features. You can add custom parts into this. At the same time, I have also created a custom feature called as forming tool. Suppose I want the sheet metal to be attached. So I'm just going to make use of something like this locking lens. And I can actually define the position that it actually has to sit. And I'm just going to flip the tool right over here and I'll just click OK. You can see automatically this particular design is going to get attached to it. So such complex things, you can just save it and you can reuse it as many times as you want. So that's a time saver, right? So let's just quickly jump to the next model. So one of the emerging technologies is 3D printing, right? And SolidWorks has always embraced this. So right now, what you can do is you can just save your files, and 3D printing usually happens with 3MF files. You can just use your 3MF right over here, and along with that 3MF, you can also include your appearances and whatever materials that you are defined, you can just include in that. Also, in SolidWorks, you have something called as Print 3D. What this basically does is it has a list of your printers right over here, you can see, and different printers have different kinds of serial numbers to it, and each of them is going to have its own workspace. So for example, if I click on this particular one, I'm just going to give it a plane, and you can see the printer work volume, whatever it is there, you will be able to take a look at it. At the same time, if you want to check whether this particular model requires some support or not, you just say show supports. And wherever the green faces are there, that means it requires some supports and the yellow faces doesn't. And down the line, you can also check whether you require some particular thickness for this to be manufactured. So all these kind of information, you can actually gather it when you're working in SolidWorks. So that's a little bit about how we can actually do your part designing in SolidWorks, how it makes it helpful when you have design library and all the smart features in order to get your work done. Let's talk a little bit about how SolidWorks is getting handled by assembly. So let me just open one model. So we all know that actually SolidWorks is pretty good at handling assemblies. And whenever you're in the assembly environment, you can actually make your exploded views, you will get the bill of materials and so on. But let's talk a little bit about large assemblies because industrial equipment is going to have a lot of large assemblies, right? So over here, if you see, we can actually open, SolidWorks has introduced something called as LDR, which is actually going to open your models much, much faster. So you can see there are certain things that we can do with it. We can actually do some cross sections. We can inspect the model. We can insert components, delete components, and so on. So I'm just going to click OK. Just notice how fast it is actually going to open. And with the click of a button, it is actually going to open the entire model. So here you can actually take a look at the section views. You can inspect the internal components of the model and so on. You can insert new components into this particular field. Now, let's take an example of a different assembly over here. Let's make use of this particular assembly. Now, this particular assembly has camera housing. At the same time, it has some LEDs and a few brackets attached to it, few fasteners and everything. So in this particular assembly, I want to check whether there are some interferences. So I can just click over here and automatically SolidWorks is going to calculate all the interference. If I want, I can save this particular result and I can also save it using the thumbnails. Once I save it, it will be saved as an Excel format that you can see right over here with different snapshots of wherever the interferences is and what is the volume of the interference you'll be able to make out. So all this information you can actually use for your collaboration among with your teammates. And over here, let's take one more example. Let's talk about this transfer card. So over here, if you see, there are some holes, right? Let's just take a look at how these holes are created. Now, if you see over here, these are tapered holes. You can see it has some intelligence attached to it. And in our design library, we also have something called as toolbox. Now, in this toolbox, you'll be able to find different kinds of fasteners of different builds and different sizes, which you can directly drag and drop. Otherwise, the easier method would be to directly add it using one of the smart capabilities. You can just click and you can just tell that this is the fastener that you want to add. You can see it is captured. I'll just say add, and automatically the fastener with the same size is going to be attached not only to this, but to the entire assembly. So like this, you can automatically do it. Right over here, you can see everywhere it is actually attaching. You can also change the size of this particular fastener according to your wishes if you want to change it. Otherwise, the computer is automatically going to capture everything. So that's a little bit about how you can intelligently make your assemblies, how you can use all the smart features and the various capabilities of report generation in order to collaborate with your teammates. Now let's take a look at how we can actually do drawings, how SolidWorks is going to handle the drawings part of it. Now we already know that when you are talking about SolidWorks, that drawings is something that SolidWorks excels at. You can automatically create your dimensions. You can automatically create the bill of materials, whole tables, cut list, everything that you want is actually going to be taken care of, right? Even the dimensions is going to be automatic. Even the bill of materials, even the ballooning is going to be automatic and everything. But when it comes to large designs, let's take a look at how SolidWorks is going to do it. So for large designs, we have something called as a detailing mode. Just take a look at how quickly the SolidWorks is actually going to open this. Now in this particular mode, you can actually do something. You can add some annotation notes. You can create a few uh, detailed views or break views, all those things. So let me just click OK, and you can see with the span of a second, it actually opens the files. And you can see automatically everything is created and SolidWorks has that capability. Now let's just go into a little bit of the detailing part. Over here, there's some break views that is created. So I'm just going to create some break views on the top as well. I'm just going to click on this view and I'm just going to break it into different parts. Let's also add a few dimensions to this. So there are different break styles that you can make use of. So let's add a few dimensions. I'm just going to add it. And I'm just going to click on the lines and the dimensions is going to be placed. Now, suppose if you feel like there's a need for some detail views, so let's add a detail view over here. Now, this detail view also needs to capture a little bit of the hole information over here. So in SolidWorks, you can actually directly call out the holes. So I'm just going to click on the hole callout, and you can see automatically the hole information is added over here. Now, suppose you want to add some more information like the length. So I'm just going to add it right over here. And if you also want to add some tolerances, you can also add it right into this dimension. Let's just, there are different tolerance types that you can actually select. I'm just going to select one of the types and I'm just going to change the value, let's say 0.01. And you can see it is automatically updated over here. Now, this is not just a blank text. It actually has meaning. It can be captured in inspection. It can be captured for your manufacturing as well. So that's a little bit about how you can do your 2D drawings. Now, 2D drawings is one part of the story. But let's also take a look at how you can actually do your 3D drawings, right? So I'm just going to open a model. Now this is a sheet metal model and you can see 3D dimensions attached to it. There are control frames over here. There are datums being called out and there are different views that have captured this. You can see all the dimensions have actually been added in 3D and that's completely movable. Also, along with this, we have added a flat pattern. Now, in that flat pattern, you will be able to see all the bend lines and everything. That is going to be helpful down the line, right? For manufacturing and everything. Now, once you're happy with what you have created, you can actually save this into a PDF. So all you have to do is publish this into a 3D PDF or e-drawings, anything, and you can add all these views. And over here, you will be able to see all the custom properties that you have created is already taken care of. And in the attachment, suppose down the manufacturing line, you actually want to attach a DXF file for the reference. So you can just add a DXF file like this, and you can directly publish it. Once published, the other side, the manufacturer just has to have some Adobe reader, and he can actually view this document. He'll be able to see all the views. He'll be also be able to take section views. He'll be able to see the bend tables and all the custom properties that are attached to this particular model. Now, if you see all these dimensions, now these dimensions are not something that we created one by one. In MBD and in SolidWorks, what we can do is based on datums, we can actually give your measurements or your annotations or whatnot. And you just have to select the appropriate datums and the features, and automatically the features or the annotations is going to get added. So that's like an added advantage. So based on your template, it's actually going to do it. So that's a little bit about how Solidworks is going to handle your drawings, how we can actually add PMI information, that is your product manufacturing information, and how that information is something that is actually going to be carried forward down the line for your inspection documents, for your manufacturing documents, and everything. It is actually going to be a lot helpful. Now that's a little bit about product development. Let's take a look at how marketing content has to be created. So for that, I want to play a small video. Just go to the video. Hmm. So whatever you can see over here, these are all images that was actually created in SolidWorks Visualize. All the animations, everything you can actually create. Now, before I explain a little bit more, let's play a small game. On the left side and the right side, you can see two images. I actually want you to guess which is a rendered image out of these two. So I'm just going to launch a poll. You can see the images. I'll give you 5 seconds to see it. And once I launch the poll, I just want you to guess which is a rendered one and which is a real one. So I'm just going to launch the poll. Quickly give a vote. Let's see which is a rendered one, which is a real one. Almost 70% is guessing that right side is an actual rendered image. So let's just take a look. Let's just take a look at the answers. So I'm just going to go forward, and actually the left one was a rendered image and the right one was an actual photograph. So let's do this one more time. Let's just see the image quickly before I launch it. Don't see the answers. Yeah, let's see. Yeah, I think everybody saw that it's a right side. That's an actual image. Yeah, it's fine. But the basic point is you can see how SolidWorks Visualize is going to make images so realistic that you can actually not tell which is a real one and which is a rendered one. I'm closing the poll. Let's quickly go ahead with the PPT. So the right side was the actual image. So when you're talking about visualize, it can actually create from your CAD contents realistic images just by adding some materials, just by adding some appearances, a little bit of lights and camera angles, and you can get really good images along with animations. And the best part is you can even create your VR and AR content. And even HTML contents you can actually send to your customers. They can also visualize it using just a Chrome browser. That's more than enough to handle visualize. So let's talk a little bit about the technical documentation part of it. Now, whenever we are going to purchase a new product, we have some manuals like this, which is a little bit difficult to understand. Even the person who creates the manual, for him also, it's a little bit difficult to convey the assembly instructions or maintenance or whatnot. And even the person who is reading it, for him also, it's a little bit difficult. So let's take a look at how Solidworks is actually going to take care of this particular part. So we have something called a Solidworks Composer that is actually pretty good at creating these assembly instructions, maintenance manuals, and so on. So over here, you can actually see this. Now, this is going to be an HTML content. Basically, any browser can actually open this, and you will be able to see all the contents. Whatever you're seeing on the screen, you will be able to see it using a Chrome browser. And you can also give some instructions like what to do, which parts to actually pull out. And you can also use arrow marks, detail views. You can also use different kinds of annotations in order to convey your model properly. And everything is actually interactive. You can even make this particular model interactive. For example, if I click on this particular top half, you can see a detail view. Like this, you can make every part of it interactive. You can also switch between configurations that you have saved in SolidWorks. You can also switch to an animation, and you can see the animation is going to tell how to rotate the screws, how to pull it out, which components has to be removed, and then next which components can be done. So like this, you have a completely interactive content that you can actually go for. So that's a little bit about how SolidWorks Composer is actually going to help you in creating all your manuals, instructions, and so on. So let's finally talk a little bit about the validation and the analysis part of it. Now, Solidworks has always been a great admirer of working out your models, checking whether it's going to work in the real world scenario. And by doing this, you can see that there are several solutions for this. There can be structure analysis that can actually do linear static analysis along with motion analysis and fatigue. And in Simulation Professional, you'll be able to see that you can actually optimize your designs. Basically, the solution is actually going to tell you where to remove the material that is excess, where it is not required, and basically on with its reference, you can actually build it. You can also do a little bit of frequency analysis, and you can also do a design study where you can vary the parameters and check which is the best design that you actually want to do. And in Premium, we have the capabilities of dynamic simulation along with nonlinear and composites. And if you have some CFD analysis that has to be done for electronic cooling and HVAC, we have that. And for basically injection molded parts, if you want to check whether your particular mold is filling up properly or not, if you want to check whether there's some shrinkage losses and so on, we have the plastic solution for that. So basically, when you're using SolidWorks analysis tools, what you can expect is you will be able to decrease a lot number of prototypes. Basically, whenever you are doing designs, finally you will be prototyping. The objective is to decrease the number of prototypes so that you can save a lot of time. At the same time, you can also save a lot of cost because you don't have to prototype that much. At the same time, people also tend to find a lot of material wastage because if you have over designed your parts, how will you get to know before analyzing? So if you have analyzed it, you will get to know that here in this particular area, material is being wasted and that I can actually remove. So material wastage can also be removed, and it basically gives you an idea of the working of your entire product before it is actually manufactured. And that's the general idea, that's the time saving idea, and that is actually going to be helpful. Over here, you can see two simulation examples that I have posted. One is a basic structure analysis, the other is a flow analysis. Basically, that robot, if it goes to that a petroleum tank, how it is actually going to how the flow is actually going to happen. So that's a little bit about how we can have SolidWorks working with us, how SolidWorks is actually going to help us in doing our industrial equipment designs. And now my colleague Sindhu is actually going to explain a little bit about the electrical and the collaboration environment that I was talking about in SolidWorks. So let me switch quickly to her.
Hi, good morning all. So I think you're able to view the screen. So I'm Sindhu, dealing with electrical and PCB suite of products. So I'll be handling all the issues or with respect to the SolidWorks PCB and electrical applications, I'll be handling it. So in today's webinar, with respect to the industrial equipment designs, let's see how SolidWorks electrical can help us in getting the better designing with respect to electrical or PCB suits. So first, let's talk about the typical industrial scenario. So when it comes to any industries, there will be a market competition. So the designer has to first look for what is the competition, what they are facing in the current market. Then based on that, they'll have to deal with the design time. So with respect to the project, what end product they have to get it. Based on that, they'll have to work on their designs, keeping the market competition in their complete project process. Then as the time increases, they'll also have to check, they have to relate with respect to the cost as well. So when they just look for cost, due to the market competition, sometimes there are chances that the low quality or the projects with lot of errors or wastages can also be seen due to the number of errors or due to the number of revisions. The type of designing also takes a lot of time, so due to which the productivity also reduces. So keeping in mind all this, at last the product delivery date will also be reduced. So this is the typical challenge what any industry people will be facing. So then to deal with with respect to the SolidWorks electrical or with respect to the electrical design challenges, what the electrical designers will face is the manual wiring and the device numbering, meaning the serial number. If we have to do it manually, there are cases that the designer might skip few of the numbers or repeat or duplicate few of the numbers. So the auditing process also takes a lot of time. The number of revisions for auditing will also take a lot of time, due to which the product cycle time increases. So they have to reduce this. And next comes the symbol customization. So if we have to create symbol for each and every project, it takes a lot of time. So there needs to be a certain library which is to be provided by the tool, where they can create it at once, or if there is library already available, they can make use of the same library rather than creating it every time. And then comes the terminal strip. So with respect to the terminal strip, there has to be a wire or cable detailing which has to match with it. So there are chances that there will be a mismatch, due to which the terminal strip drawings might take a lot of time. Even there, they have to do the manual process and generate the terminal strip drawings. So the time as well increases here. Then comes the cabinet layout. So even here, the symbol plays a very important role, where they have to just, before going to the 3D world or before going to the installation process, the designer has to know where the components need to be placed, what should be the distance between each of the component. All those needs to be taken care before going to the real process. And then comes the bill of materials. So before releasing the after completing the drawings, if they have to give the bill of materials, or if they have to know what are all the components which are used in the project, they have to just cross check whether all the design components specifications are matching with each other. All the ratings, whatever they have defined in the manufacture part, if they are matching or not, that needs to be taken care. And then comes the quality. So which they also have to look for the quality which might impact in the design cycle time. So all this needs to be considered before coming to the final process, due to which as the quality reduces, the project cost and the timeline will also be a major cause. So all this needs to be taken care. Let's see why SolidWorks Electrical is important. So here in SolidWorks Electrical, we can automatically do the ferrule numbering, which takes a lot of time. And then we have the enhanced component library, where we have the electrical content portal as well, where most of the symbols, manufacturer parts, cable libraries are available already. If it is not available, we can customize the library as well. Then comes the terminal strip. So here, once placing the terminal strip and assigning the manufacturer part, we can generate the automated terminal strip drawings. So we need not create the terminal strip drawings, where the manual process might take 2 to 3 days of time. Then comes the cabinet layout. So here the cabinet layout, the rails, that's whatever the manufacturer part we have assigned, we can place it. And also once we are placing the component, we can define what should be the space between each of the components. So all these options are available here. Then comes the data synchronization, meaning when it comes to any other tool, there will be disconnect between each of the tool, meaning one might electrical designer will be working in a different tool with electrical interface. The mechanical designer will be dealing with other tool, where there will not be any collaboration which will be happening continuously. So there will be a mismatch, or they have to convert the data formats to neutral formats, and then they have to import where the data losses are high. Then comes the real-time DRC check. So after completing the schematics, they also need to take care whether they have placed all the components with the manufacturer parts and they have routed all those. So the design rule check is also available, where the quality of it will also be increased and the wastages will be reduced here. At last, we'll also see how SolidWorks Electrical will integrate with SolidWorks CAD. So we'll see what is the typical electrical process any industry follows. So first is the schematic, that is the electrical designer initially start from the scratch with the schematics. Once the schematic is done, the next process is to integrate with the 3D mechanical CAD, where the cabinets will all be designed by the mechanical designer. So here, when they are working with this integration, there are too many challenges for electrical and mechanical designers, because the mechanical designers will have certain specifications which needs to be met. Similarly, the electrical designers will have their own specifications. So there will be a lot of confusions and a lot of time taken over here. If there is any file-based exchange, it will take a lot of time. Then once the 3D CAD is completed, last process is to release the drawings and move for the production. So here, let's see the SolidWorks product demo, how SolidWorks can help us in getting the collaboration and all those done. Before that, we'll just see what is the agenda, or what is the design workflow. So first, we'll see how the schematic design is done with the help of SolidWorks Electrical 2D. Then we'll see how we can configure the PLCs and design the terminal strip drawings. Then we can go through the cabinet design, that is the GA drawings, and the 3D collaboration. At last, the design rules and the documentation process. So let me just explain you what interface I'll be using. So the interface currently, which is shown on the screen, is SolidWorks Electrical 2D schematic, and this is the SolidWorks Mechanical CAD, where I have got my designs from my mechanical designer. So for this particular assembly, we'll be doing the routing. So moving to the SolidWorks electrical interface. So as I told, in schematic, electrical designers will deal with single line designs and the complete, that is the either the harness or the complete schematic designs. So if we go with single line designs here, as you can see, we can design the PCB. So from PCB, I can just insert the connectors from which the cables will be drawn. So for this, we have the library. So as you can see here, for a line diagram, we have separate library which is available. So based on the connectors what we are using, we have different types of library. As you can see here, in single line designs, we use pictorial representation. Why pictorial representation is because when we release the drawings to the layman, sometimes it's not that electrical designer will be at the installation process. There can be the lineman who will be taking care of the installation at times. So even for him to understand it, it shouldn't be difficult for him to understand. So with the help of this picture representation, he can just view the pictures and start rigging up the circuit. So this is one advantage. So here we have the wires and cables options to connect between the connectors, so we can just select it and start to draw. So this information you can see here, what is the detailed cabling which is used. So here we have an option called add cable. So this has got the library what SolidWorks electrical offers. So with respect to what is the reference and which manufacturer we are looking for, we can just filter it out here and we can assign the particular cable with the manufacturer path. So once completing this single line designs, the next thing is we'll be moving to the mixed schematics. So here, even in the mixed schematic, we have the library. So here you have a separate command. Why this is separate? Because sometimes there are cases that when we are dealing with single line drawing, we might get confused with the commands. So to avoid this confusion and just going to wrong type of commands, we can just make use of the same which we are using currently. And here in insert symbol, we have just like the single line designs library. Even here we have library with different classifications. So we can go to the appropriate classifications and we can start to place. So here we have connectors. So based on the number of pins what we want to place, we can just select the type of connector. As soon as I select the connector over here, when I get the connector onto the schematic, when I place it, we can see automatically a symbol properties panel pops up. So this panel will allow us to give the automatic marking. So if usually this process when we are dealing manually or when we are using the AutoCAD, it will be manual process where we have to just enter or start to write the markings. So here we need not look for that because the tool will automatically take this process. So it will automatically start to give the number based on the previous component which is placed. So here the class will also be defined by it because we have chosen from the connector library. And then here we can define what is the location based on the installation type where it is being placed. All those we can define, like selecting the location and what type of function it is doing. All those we can define. And also here, if we are drawing any terminal types, that is the terminal strips, if we want to add, we can just select the type of terminal strip. There are different types like diode, disconnectable, earth, fuse, LED, and the fuse and LED types. So we can define based on our requirement, and also we can choose what type of terminal strip symbol we want to place. So like this we can assign everything here, and then we can proceed with the manufacturer part. So here you can see before assigning any manufacturer part, the tool suggests what is the number of circuits that particular symbol has. So based on that, we can just go to search for the manufacturer part. Here we can look for what manufacturer part we are looking. And then once we search here, it shows what is the number of circuits and what is the terminals. So based on our requirement, we can just choose a manufacturer part and assign it with the respective manufacturer part. So here I have already placed the connector, single pin connector, where it has taken all the informations what I wanted to assign, and also here the manufacturer part is assigned. So the manufacturer part contains informations like what is the reference, who is the manufacturer, what is the terminals, what is the circuit. All the informations will be added here. So after creating or after completing the schematic, next thing is to, if we have any cables which needs to be associated, we can assign it. Or if we want to, after placing the component, if we want to rig up the circuit with the wires, we have different types of wires, that is single wires and the multiple wires. What exactly this multiple wire mean is, if we have phase type of wires, like different phases, we can just go for multiple wires and start to route the circuit with different phases. Or if it is a single wire, we can make use of draw single wires and rig up this circuit. Then even this is not just a dumb line with different colors associated to it. The wire has got all the properties, like what is the diameters, what is the sectional gauge, what is the wire size standard, wire color, and we can define the bent radius, linear mass, whatever the real wire in real time the wire has got all the properties, the same properties can be defined here. So these all informations will be captured in 3D, and the same type of routing can be seen in 3D. So after completing the single line design, so if we have to associate the wires with cables, so here we have an option called associate cable course. So based on our requirement, we can just go to new cable and select the type of core which we want to assign. So here I have assigned 8 core 22 AWG standard cable to this particular wires, and I have completed my schematics. So after completing this complete schematic, sometimes if we have any PLC designs, we can deal with the PLC designs in SolidWorks Electrical as well. So there are two ways of generating the PLC drawings. One is the manual process, where we can get the symbol onto the schematic and then rig up the circuit, or there is an automated process where I can just choose what is the PLC manufacturer part which we want to add, and then we can associate the macros, meaning so the part of the circuit what we want to assign can be saved as a macros in library, and then we can make use of those small circuits. And once all the channels of PLCs are associated with that macros, I can just click on generate drawings, where it will without any manual process of adding wires or symbols, we can generate the automated process. So here you can see the fifth sheet with name PLC drawings is created. So this is how, where I have just assigned selected the manufacturer part, and I have just given the macro circuits. So it has automatically created the automated PLC drawings here. So coming back to the PPT, so with respect to the schematic, so we saw how automatically the component definition was given, and also the single component association, whether it is a single line or a schematic, how the component association can be done. And then we saw how the cabling or wiring could be done. And with respect to automated ferrule numbering, so with this project, I have just started with the schematic where I have completed the circuit. So if I have to do the manual process of numbering the wires, it takes a lot of time over here. So rather than that, as I told, wire has got certain properties. So here we have equipotential formula and wire formula. So based on this formula, we can just define what type of ferrule numbering we want to carry out for this project. And once I click on this option, within few seconds, I'll be able to get the numbering of those wires based on my requirement for the whole project. So here you can see the ferrule numbering is carried out for the complete project. And then as I said, we can generate the PLC drawings. That is, one is manual method and the second one is automated method, that is the formula based PLC channel addressing. And also we saw how the automated terminal strip drawings can be created. So once the terminal strip is added to the project, the next thing is, if I want to generate the terminal strip drawing, there is an option called terminal strip. So if we have any terminal strip, we can just select it, and once we click on generate terminal strip drawing, it will automatically generate the terminal strip drawing for the complete project. So you need not create it manually. So next step is GA drawings and the 3D collaboration. So let's see how the GA drawings can be created in SolidWorks Electrical. So here, as I told, we have the library for the 2D footprints. So based on the type of classification, we can just go through. If it is a contactor relay, we have different types based on the reference number which is defined. And even here, for the connectors, different types of connectors are also placed. So you can just, based on, as soon as I select the GA drawing document over here, So it will open up a panel over here for the components. So when I expand it, whatever the components or the symbols I have placed it in the schematic, all those will be visible here. It's just that I need to right click and click on insert option, so that it will insert the connectors onto the schematic. So here I have generated the GA drawings by placing the connectors over here, and we can also see the route. So here we get the connector tables as well, where we can see the informations like what is the pin number, what is the color of that wire, which connector is connected to which connector, that is the origin and destination connector, all the details will be seen. So like this, we can start to place the symbols from this components panel, and then we can generate the GA drawings. So after completing the schematic and after generating the GA drawings, now we'll have certain idea like what should be the component placement, where it has to be placed, and all the details. So with respect to that, we'll have to continue further with the mechanical assemblies what we have. So for the schematic which we have created, we can just go to the 3D assembly. As I told, this was created by my mechanical designer. He has shared me the complete assembly. So for this, if I have to, these are the connectors which it's being drawn. Now, if I have to carry out the routing, I can make use of the SolidWorks electrical 3D add-ins, which is available on SolidWorks CAD. So with the help of this options called route wires, route harness, and route cables options, which is available here, I can make use of the appropriate one. So if I'm going with the routing wires, I can make use of route wires. Since I want to carry it with the route cables, I'm just choosing route cables. So here there are different types. So I can make use of this route type selections, where I can create the route harness or route cables with respect to SolidWorks route. So what exactly the SolidWorks route mean is, since we have defined the informations or the properties of the cables and wires in 2D, here it looks like a real wire or cable. So as you can see here in real time, how you the color or the wire can be seen here. If we want to proceed with the 3D sketch with the color what is defined in the schematic, it just defines the sketch. So like this, we can make use of this option. And then there is a render type, like here you can see at the cross ends, at the bend types, there is a spline which is taken, that is smooth curve. If we want that smooth curves, you can make use of this option called use splines. If we want it straight just like lines, we can make use of this option called lines. And then with respect to the route to cables, there are different types. If we want to just carry out the cabling with the selected components, or with respect to the selected cables, meaning when we are adding the cables to the project, there will be different types of cables which will be assigned. So based on the cables, if you want to route, you can route it, or if you want to route all the cables with respect to this assembly, you can make use of it. Once all the information is set, you just need to click OK. So here the information is given, like the route cables are being routed. It is doing from to list from the 2D schematic. So it shows which is the core cable which is routing. So I had assigned a 8422 AWG standard cable. So the same cable is being routed. You can see here the route is being created based on the path which is defined. So usually it will take the smallest path. If I want certain path which needs to be carried out for that particular route, I have this create route path. So based on the 3D sketch which is being drawn, it will take the same path. So here you can see with respect to the connector from the PCB, how the routing with the same colors what is defined in 2D, it is taking the same color. And even here the end type, how it is being connected. So like this, we can make use of routing. Once the routing is complete, based on the origin and destination component placement, it will give us the cable or the wire lengths in the bill of materials. So before going to the bill of materials and all those, we'll see how this PCB is being generated, how this the complex shape of this board can be generated. So the usual processes, the PCB designer will be having the board shape, where he will be completely redefining the board shape in the PCB tool. So if he has to design this particular board shape, he might take at least a day or half a day to do it. So, but what is good thing with the SolidWorks is, just like we saw the integration or the collaboration of SolidWorks electrical with mechanical, even the PCB tool will give the seamless collaboration with the mechanical tool. What will happen is we have a single interface where we can do the schematic and PCB board in SolidWorks PCB as well. So here we have how this collaboration happens is here we have this SolidWorks PCB collaboration panel. So with this collaboration panel, just I can seamlessly collaborate with SolidWorks. So we can create the schematics in this SolidWorks as well. So this is the default board which we will be seeing. So if the electronic designer wants to define the shape, he has to go to board shape options and make use of these options which are available and start to get the board. So it is not that easy with the help of this board shape option, because the electronic designer has to contact with the mechanical designer, understand what is the shape of the board, what are all the dimensions which he has carried out, what is the constraints with respect to the mechanical enclosures. All this he has to understand. So there will be a meeting or a file-based exchange which will happen between two of them. So it takes a lot of time for them to get the required board shape. But here, what is good and unique is we have this collaboration panel. This collaboration panel will, they need not meet physically and discuss about the design constraints or what needs to be taken care or with respect to their project. With the help of this collaboration panel, they can make use of the chat window where whatever the information the electronic designer has to communicate, he can communicate, and whatever the mechanical designer has to communicate, the same panel will be available on the mechanical interface as well. So as you can see, what we have done is we have just sent this default board shape by setting the layer stack up, what should be the number of layers, all those, and we have asked the mechanical designer's help to get the required board shape done. So the mechanical designer, with the help of this convert entities options, he has just created the board and he has sent us back this board. So within maximum like 3 to 4 minutes, we can get we have got this required board shape. So if it was supposed to be drawn completely by electronic designer, it would have taken almost half a day for him to get the required board shape. And it is not that at a single shot we'll be able to get the design when we are doing it manually. There are certain revisions which needs to be taken care. So all this time process is cut short over here, and we can complete the project in the given time. So this complete PCB board and the routing harnesses and the cabling, whatever you are able to see, is completely carried out in SolidWorks. So after completing all this routing process, the last process, as I told, is to generate the deliverables. So that is, we have to just cross check what is the design rule check, and also we have to go through what is the documents which we have to share to the end customer. So here, coming back to this, we have design rule check. So this design rule check will help us in understanding if there is any manufacturer part which is not assigned, or if there are any dangling wires, or if there is any wire which is not connected properly, or if there is any empty terminal strips, if any wires is not routed in 3D. Also the duct filling ratio, everything can be seen here. So rather than just releasing the drawings, the designer can also cross-check if there are any errors within the project. It's just that we need to check in. Once it is checked in, if there is any errors, it will be listed in this blank space. If there is no error, it will be just blank, where the designer can later share the this particular report with the help of Excel format, text, or XML formats. After checking the design rule checks, and if there are no errors, the last process is to generate the reports, where we have different types of configurations which are available, what electrical designers will look for. So we can just get the list of cables, drawing list, bill of materials. Then we have list of wire styles based on the line style. Then if we have carried out any harness designs, what is the list of cables which are used in harness, all those can be done. And also PLC input output list can also be seen here. Once it is done, you can see all the origin and component marks, what is the section gauge, all the details can be seen here. The bill of materials with respect to the reference number, mark, description, what is the quantity, who is the manufacturer, all the informations can be seen. Just like the design rule checks, even here we can put it in So with this, we can see how accurate and unified the electrical and mechanical bill of materials are. And we saw how enhanced the report generation formats are available in SolidWorks Electrical. And we also saw the list of wire cables where from the 3D, all the length of cables and wires were updated. And also we can generate the cut list of this. So with respect to whatever we saw in 15 to 20 minutes, we can say that SolidWorks Electrical helps us in reducing the manufacturing defects and scraps, and also reduces or eliminates the hidden costs like the wire wastages. All those can be reduced by understanding what should be the length of the cable or wire. And then we also saw how streamlined the processes where after creating the schematic, we just went to the SolidWorks. With the help of collaborations, it was easier for us to do the integration with two tools rather than converting it to neutral formats and spending much of time over there. And we saw how automatically the schematic generation and documentations are. And we, with respect to all this, at last the project will be finished in the respective deadlines, and also it increases the productivity and also the time to market. So with this, I would like to conclude the electrical session. I would like to hand it over to Karthik again.
Thank you, Sindhu, for showing us how we can actually collaborate our electrical designs with mechanical. So before I conclude, I want to summarize a little bit about what we have seen so far. SolidWorks is actually going to give you an helping hand from the concept designs to your end stages of your product development. Basically, if you want to do any kinds of CAD solutions, you can just do your part mounting assemblies. You can also integrate or collaborate with your electrical designs, PCB, and so on. And once you have done those designs, you can validate it, test it, whether it's going to work in the real world scenario. You can also, by doing this, you can reduce material wastage, you can decrease the number of prototypes, and finally, you can also co-create along with your mechanical designs, your marketing content for your assembly instructions, could be your maintenance manuals and rendering images. So with this, we will be closing the session. But before we close, I want to ask if there is any questions, you can directly pop us in that chat window. Just write your questions. We'll be waiting here for 2 minutes. If you have any questions regarding of any of the solutions that you have seen so far, you can just type and we'll be answering your questions right now. So I'll be waiting for 2 minutes. Just type your questions in. Mr. Manjunath has asked whether the composer documents that we have created, if it is actually automatic or we have to sit and create. Actually, Manjunath, we actually have to create it. It's not automatic. You don't require any kind of CAD knowledge. You can just use Composer without any CAD knowledge, and you can actually create those contents, whatever I have showcased, quite easily. You don't have to worry about that. There's another question from Mr. Rakesh saying that how much time does it actually take for the renders? Now, depending on your system configuration and depending on the graphic cards that you're using, it is going to take some time. And we also have a queue system where you can close the software and automatically, just like how your Chrome downloads your stuff in a different window, automatically in that queue manager, everything that you have put it for render, it is actually going to render altogether. I hope that answered the question, Rakesh. So far, I don't see any questions. If you have any questions, you can directly contact me. There's my mail ID, karthikpal@beacon-india. If you have any questions related to electrical or PCB, you can directly contact Sindhu. I have put a mail ID right over there. I have put also my phone number. You can directly contact me and I'll be happy to help. And if you want to check any additional contents or something like that, you can just go at info@beacon-india.com, and tech support, you can just mail us and we'll be happy to answer. Stay tuned for additional webinars that is coming from Beacon, and you'll be able to learn a lot. Thank you, everybody, and thank you for attending this webinar and closing the section. Thank you.